All right, Trinity Classical Academy, we are back in action. They tried to stop me, but they could only hope to contain me, and they failed at that too. Oh, I was going to post a joke of the day. Let me do that now. I forgot about it until just now. Hopefully you guys are doing really good. And let's see, where's that joke? Date modified, didn't I do it? Oh, forget it. It's somewhere else. How about this? How about a knock-knock joke? Knock, knock. Knock, knock. Okay. Cow says. No, cow says moo. I guess it's really better with two people. Doing it by myself with a microphone just really, it lacks a certain amount of punch. All right. So, students, we're going to get into the real meat and potatoes of probabilities. We're going to start with some vocab. And looking at the vocab, I've realized that there is some vocab that I use differently that I was trained with. So I'm going to try to stick with the vocabulary as it's used in your textbook. However, I might accidentally use wrong vocab words because I learned it just a little bit differently. So potato, tomato, to each his own, or whatever on that. So we're gonna start by understanding outcomes, events, and sample spaces and how they apply to everyday life and doing probability analysis. That seems really big. I'm gonna zoom out a bit. There we go. All right, so the outcomes and a sample space for an activity. So whenever you play chess with your friend, I'm reading from the book, the game could end in three possible ways. You win, or you lose, and that means your friend wins, or there is a draw. All the possible results of an activity are called outcomes. That's a vocab word. Outcomes. In the case of chess, there are three possible outcomes from your perspective: win, lose, or draw. The collection of all possible outcomes from an activity is known as the sample space. Sample space. Flipping a coin. When you flip a coin, it will either land on heads or tails. The activity has two possible outcomes: heads or tails. Rolling a die. We're talking about, again, I've introduced polyhedral dice on the last one, but most people, when they think of dice, they're talking about the six-sided dice that we're all familiar with the little dots called pips. So a number die has six face values. When you roll it, it'll be 1, 2, 3, 4, 5, or 6. Those are the possible outcomes. And they say anytime you do something like roll a die or flip a coin, this is the math note, they often call that an experiment. I always learned that we called those trials. So like you flip a coin 100 times, that's 100 trials. And then you record the outcome of the trials. So the weather forecast, they use 6 possible outcomes: sunny, partly cloudy, cloudy, rain, snow, or thunderstorm. So that is defining your sample space is the critical first step to solving any probability problem. Let's turn the page, because without being able to define the sample space accurately, you're going to do badly. We call it being wrong. I want you to look at the hands-on activity on page 246. We don't have to actually use cards, but you certainly may if you want to. It'd be super easy to do. Get 4 cards, right? A 1, 2, 3, and a 4, and then you can like mess around with them. Let's take just a moment. I don't expect you to spend like all day on this, but like just a short amount of time. We're gonna pause the video, and we're gonna do the hands-on activity. But before you pause, so you're gonna form a 3-digit number, write down the answer, and try to see if you can find all of the possible 3-digit numbers that you can form from a 1, a 2, a 3, and a 4. You may not use the same number twice. 3-digit numbers only. Ready, set, go. Pause the video. Righty-ho then. So this is some advanced counting, and there are different ways and methods to do this, like permutations and whatnot, ways to count organizations of numbers. But supposing we had these cards here. I like to just briefly, I guess we'll check them. So like, obviously we can start with 123 as a number. We can then do 124. We could then do, so let's start with the 2. 213, 234. We could start with the 3, 312, 324. We could do 4, 12, and 423. What I did was I just went from kind of the left to the right. We could also do them out of order. So I did 123, but I didn't do 132 or 142 or 143. So if you start with 1 and then exhaust all of the numbers that could possibly begin with 1, then you know, aha, there are 6 results that could begin with a 1. 123, 124, 132, 134, 142, 143. Do that same activity for the 2. You might even just physically move the 2 over here, start with the 2, and then go, okay, 212, you can't do 12, 213, 214, 231, 234, 241, 243. We have 6 different 3-digit numbers that could begin with a 2. Notice a pattern? So there are 6 numbers that begin with a 1, 6 numbers that begin with a 2, 6 numbers that begin with a 3, and 6 numbers that begin with a 4. There are a total of 24 different 3-digit numbers that you can form using the numbers 1, 2, 3, and 4. Fun times, you guys. I think it's interesting. An interesting exercise in creative problem solving. How to do that. You can also do a tree diagram, which they show briefly. And a tree diagram is interesting. You know that, so if we assume that there's a 50-50 chance of a baby being a boy or a girl, exactly 50% chance, and someone has, or a family has 4 kids, the likeliest outcome is that there will be 3 of one gender and 1 of the other. Most people think it'd be 2 and 2, 2 boys, 2 girls. By using a tree diagram, you could illustrate that it doesn't work that way. So the tree diagram goes like this. So the first number is a 1. What's the second number? Well, it could be a 2, it could be a 3, or it could be a 4. So if the second number is a 2, then what's the third number going to be? Well, the third number could be 3, or the third number could be 4. And if we go with 3 next, then the third number could be 2, or it could be 4. And if we go with 4 as our second number, then the third number could be 2, or it could be 3. And then we can see here we have all 6 results. We have the number, you just follow the tree, right? So they follow the branches. So 123, there's also 124, 132, 134, 142, and 143. Every node, these are called nodes at the end of a tree diagram. Every node is a result, or is an outcome. I guess I'll use the vocab word. Every node is an outcome. So we have 1, 2, 3, 4, 5, 6 outcomes that could possibly begin with a number 1, and we have a 3-digit number formed like this. I have a feeling someone's going to be really curious about that outcome. That if you have 4 kids, you're likelier to have 3 boys and 1 girl, or 3 girls and 1 boy, than you are to have 2 boys and 2 girls. I'll leave it a mystery, and if someone really, really, really wants me to demonstrate it, I can demonstrate it. But odds are that you'll have 3 and 1 instead of 2 and 2. All right, let's look at example 1. So example 1 says, list all types of outcomes in each event, state the number of the outcomes. So first we have, you spin a spinner that's shown in the picture on page 246, and you write down the number where the spinner lands. Looks like there's 1, 2, 3, 4, 5, 6, 7, 8. They look to be about even evenly spaced apart. So the outcomes, it doesn't matter because we're not looking at probabilities just yet. We just list the outcomes. The outcomes are 1, 2, 3, 4, 5, 6, 7, and 8. So there are 8 different outcomes. So, okay, we've solved number A. Number B, you place the cards shown face down. Then you draw and record the color. So there's blue, green, purple, brown, green, and white. So there are 2 greens. So look at that math note, guys. There are 2 green cards. Because you count the repeated cases when possibly counting outcomes, there are 6 equally possible outcomes, but only 5 different types of outcomes. So the outcomes that you could, so if I draw a card out of this pile, I could get a blue card, or green, or purple, or brown, or white. There are 5 different outcomes, different types of outcomes, but 6 equally possible outcomes. I don't know that I like the wording of that, to be perfectly honest. Because I would say that there are 4 equally possible outcomes, and then one of them is more likely than the others, drawing a green card. But I guess what they're saying is there's green card A and green card B. Those are 2 distinct outcomes, but drawing a green card is one specific type of outcome. I just think that's confusing language, and so I'm going to have to apologize for how confusing that language is. Guys, let's do a pause right here. Let's try guided practice numbers 1 and 2 on page 247. Pause it, try it out, resume when you think you got it. Zippity bippity. So we're on page 247. We're doing guided practice 1 and 2. All right. Number 1, select a letter from the list of letters A, D, E, G, K. A asks for, list all the outcomes. The outcomes are, you ready for this? A, D, E, G, and K. Those are the outcomes. State the number of possible outcomes in the sample space. 5. There are 5 different outcomes. Literally the last chapter of this math book is counting. I'm not even going to lie. That's what it is. Although, I'll say this, on the CFA examination, the counting chapter was no joke. It was some crazy stuff. Because you have to count like thousands of things using math. Number 2, use the letter cards below to form all possible 3-letter English words. This one's a little more tricky. List all possible outcomes. Are you ready for this? There are 6. Did you get 6? So you get 2 letter Ds. So you could make dad. You could make add. So we're just looking at 3-letter words. So there's it, add, bad, cab. There's also cad. It's a wicked, evil, bad person. You cad. There's dab. And there's dad. Those are the 6. So the answer to B is 6. The answer to A is the list of all the words. Cool? Cool. Y'all, we are on the blue section, list outcomes favorable to an event. This is a different concept. So there's different types of outcomes, and then there's outcomes favorable to an event. So an event, what's an event? It's a vocab word, event. An event is a collection of outcomes from an activity. So if you roll a numbered die, the sample space is 1, 2, 3, 4, 5, 6. The event of rolling an even number consists of the outcomes 2, 4, and 6. So events are usually named with capital letters. If E stands for the event of getting an even number, then you can write E equals, and then you have those little brackety things, 2, 4, 6, to show the outcomes favorable to event E. Let me write this out. So if we say the event that we're looking for is E, we write E equals, and then we have this bracket, 2, comma, 4, comma, 6, and then a closed bracket. So those are the events favorable outcomes to the event of drawing or rolling an even number. So, cool. We're also going to learn, I want to introduce it before it's time. We're going to learn the opposite of an event later. So there's the event and then there's the not event. So, picking a letter. There are 26 tiles placed face down on the table, each printed with a letter from the alphabet. There are 26 letters in the alphabet. I'm talking about the English alphabet. You pick one letter. Let D be the event. So this time they're using a different word. They're using D for this next example or this next thing. So let D be the event that you picked a vowel. I don't know why they picked D. It doesn't make much sense to me. Okay, that you picked a vowel. Let E be the event that the letter you picked comes after the letter V in the alphabet, and let F be the event that the letter you picked is a consonant and comes before the letter P in the alphabet. So an enthusiastic math student says you use those brackets to show the sample space. We already knew that. We already knew that, enthusiastic math student. Keep up. All right. So D, what are the favorable outcomes for the event D? Remember, D was the event of a vowel. Well, that is a terrible bracket. There's A, E, I, O, and U, and a better closed bracket. E is the event of a letter after V. You can see it in the book. W, X, Y, Z. And F, I'm not going to write all those. You can see them. A consonant that comes before P. So B, C, D, F, G, H, J, K, L, M, N. Fun times, you guys? I agree. It's fun. Not hard. I don't think it's hard. If you're having a hard time with it, pause the video, rewind, ask your co-teacher or your friend or me. Let's see. Sorry, I'm just getting distracted. So it says, I'm supposed to tell you, the braces contain a list of items that are not the same as brackets. Yeah, you have to do the little squigglies. Okay, we're going to turn the page, y'all. Let's look at example 2 on page 248. So example 2 says, list the favorable outcomes for an event and describe the sample space. So we turn the page, we're on example 2. So, list the outcomes that are favorable to each event. Excuse me. State the number of outcomes in the sample space. For breakfast, you can choose one item from the following list. Only one item. This is it. Remember we had this talk about breakfast. Some of you only eat like a toast for breakfast. So toast is on the list. You're welcome. Hash browns, bagels, plural. I might go for bagels if I get more than one. Oatmeal, cornflakes, or scrambled eggs. B is the event of choosing oatmeal, cornflakes, or scrambled eggs for breakfast. Okay. So state the number of outcomes in the sample space. Well, the number of outcomes would be 3. Or they say, okay, never mind. So the solution is, list the outcomes. So first part, list the outcomes favorable to the event. So they say, let B be the event. So the event is B for breakfast. B for breakfast. Yeah, let's go with that. So the event's favorable. I'm using the vocab words. The event's favorable to outcome B. Favorable to outcome to event B. Favorable to event B. Here are the outcomes. So event B, the outcomes that are favorable to B are oatmeal, comma, cornflakes. They might let you sprinkle sugar, I don't know. Comma, scrambled eggs. Just draw an egg. Scrambled egg. So you may choose, so those are the favorable events, but then the second part of it says state the number of outcomes in the sampled space. So the number of total outcomes in the entire sample space are 6, because there are 6. So there are 6 outcomes in the sample space, but only 3 of those outcomes are favorable to B. You tracking with me? I'm going to say that one more time. I know you could rewind it and just listen to it again, but I'm going to say it again. There are 6 total outcomes in the sample space. There's a lot of vocab words. I'm going to write this in Galaxy Pen. Vocab. Listen to my vocab. 6 possible outcomes in the sample space, but only 3 of those outcomes are favorable to event B. And here they are. Can I make a galaxy highlighter? That'd be cool. Too bad. Okay, so hopefully we got that vocab. Maybe I'll have you repeat that vocab. Say it out loud. I don't care how weird you look in your house. We're all going crazy and talking to ourselves in social isolation anyway. At least I assume we are, because I definitely am. So repeat after me on this breakfast list. Here we go. There are 6 possible choices for breakfast. That means there are 6 possible outcomes in the sample space. But only 3 of those outcomes are favorable to event B. That's like memory work. I feel like you repeating it is really going to drive it home, so you remember exactly how this verbiage works. Groovy? Cool. Example 2, problem B. X is the event of choosing a word with exactly 2 E's in it from the following word list. Look at those words. Mathematics. Theme, eerie, share, employer, these, employee, here, there, maritime, those. So it appears that there are 11 words in the list, so there are 11 outcomes in the sample space. But which of them have the letter E twice and only twice, no more, no less? So the outcomes favorable to event X are theme, employer, here, there, and these. That's all. Everything else has more or less. Cool. Let's do guided practice, guys. Numbers 3 and 4. Pausing. Oops, that's not red. This is red. Pausing. All right, unpausing. So I downloaded an app that shows people who can see all the colors what it's like to be colorblind. It's called CVS, Chromatic Vision Simulator. And I gave it to my wife. I'm like, here, look at this. And she would not put it down. She's like, oh my gosh, you can't see anything red or green or anything. This is so sad. She literally started crying. Like I showed, she's just walking around the house, pointing it at things, seeing how things look to me. And she's like, this is really how this looks to you? And I'm like, well, yeah. And then, so I turned on the other colorblind. There's a colorblind where you can't see blue or purple. And then that looks almost like black and white to me. When I pull it up on my screen, I'm like, man, these poor guys can't see anything. And they're like, no, they could see a lot more colors than you can. I'm like, really? They're like, she's like, yes, they can see red and green. And I'm like, oh, that whole screen looks black and white to me. It was terrible. Anyway, guided practice number 3. Why is the event of choosing a prime number from a list of whole numbers from 1 to 20? Some of you prime nerds are going to love this. I love it. I love it. List the outcomes favorable to event Y. So that's all they ask. What are the outcomes favorable to event Y? They don't ask for the total sample space. Oh, they do in B, sorry. List the outcomes favorable to event Y. So how many prime numbers are there between 1 and 20? There's 2, 3, 5, 7, 11, 13, 17, and 19. Those are the prime numbers from 1 to 20, which means those are the outcomes favorable to event Y. You don't have to, oh my gosh, you don't have to list all those blanks again. Those are the outcomes favorable to event Y. And then B, state the number of outcomes in the sample space. How many numbers are there between 1 and 20? 20. There are 20 outcomes. 4. Number 4. You choose a shape from a bag containing cardboard geometric shapes. So you choose a shape. List all the shapes. Number A. List all the favorable outcomes for the event of choosing a shape with, at most, 6 sides. Oh man, there's colors involved. Good thing I have an answer key. with at most 6 sides. Okay, so at most 6 sides is going to exclude the circle. The circle doesn't have any sides. I don't know. Should it include the circle? I think it maybe should. Because the circle does not have more than 6 sides. Oh, this is one of those math controversies. The answer key does not have the circle given, but I don't know. If you guys put the circle, I would be okay with that. I would allow it. It's like a peep. You're allowed to like peeps or not like peeps. Marshmallow peeps. I'm with Taryn. I'm fine with peeps. They're not my absolute favorite, but you gotta love the mushiness of them and the dissolve in the mouthness of them. Okay, so here are the answers. Number A, list all the favorable outcomes. There's brown parallelogram. There's triangle. There's the green parallelogram. There's the square, the pentagon, and the hexagon. I just read the list in the book. Number B, list all the favorable outcomes for the event of choosing a shape with more than 4 angles. More than 4 angles. This definitely excludes the circle. If you put circle, consider yourself incorrect. So, more than 4 angles. There's the heptagon, the octagon, the pentagon, and the hexagon. All right, guys? That's it for today. This is all we got. Not too bad, I think, right? Have a healthy and well Quarantine's Day. And I'll see you next time.